Welcome, YouTube. Today, we are talking more about soldering. Well, my name is Bruce Gilson with Event Tech AV, and this is another episode of Knowledge Basics. And if you've been paying attention, you know that we already have a video specific to how to solder XLR. But we're kind of revisiting the topic because there's some details and nuances that we didn't really get into, but we don't want to make this about XLR. We actually want you to go watch that video. This is going to be more about the tools and the materials and the how-tos and the what-tos. So if you want to know more general information about soldering, make sure you stay tuned. Okay, so today we have a Weller base station solder, but let me talk a little bit about different options that you have when it comes to soldering stations. First off, our team mostly flies now. They're not sitting at a nice, beautiful table in a warehouse with power everywhere and all kinds of options. They're actually typically on airplanes going across the country to visit people like you and to work inside your facility. So the majority of our team has actually switched over to battery operated solder stations. Now, I don't have any of those with me because they're all out in the field, but let me just tell you what we've learned. Milwaukee makes an M12 solder station. And what we've learned about that specific tool is it's not great. The battery is at the back of the unit, and when you're soldering, the tip is kind of this small thing, and when you've got a lot of weight back here, it's hard to control, and so you end up having to tighten your hand a lot, and you get a lot of muscle fatigue. We've found that that tool is really good for one-off type solders. You just gotta go do something really quick, but it's not a good tool that you're using long-term doing a bunch of you're not doing it over and over again. You understand what I'm trying to get at. So the M12 tool, it's a good tool just for one-off type situations. They also have some stations that connect to the M18 battery. And the stations that connect to the M18 battery are actually a little bit more like this traditional setup where there's a base station, which is your M18 battery, and then there's a pencil or a wand, which is more like this. And we have found that the M18 has good energy, good juice. It's gonna allow you to do a lot of repetitive, I can't say that word today. It's gonna allow you to do that a lot. Repetitive? Thanks. It's gonna allow you to do a lot of repetitive movements. You're not gonna experience as much fatigue. The pencil's nice and light. So it's actually become a great tool, and almost all of our technicians now have that in their toolbox. Now, if we do have the opportunity, we're taking the truck out there, we've got the trailer out there, we've got our normal base stations, we can bring our Weller base stations. Today, we've got what they call this the analog, and the reason they call this as analog is because they've got new ones now that are digital. This one's not digital, it's got an analog temperature control, it's got, on-off switch, whatever. These are the stations that we bought when we bought a bunch of stations many years ago. We still have a bunch of them. They last for forever. Highly encourage the Weller products. And so that's what we're gonna be using today. We're gonna be using an analog Weller station. And I'm gonna get into some details about some of the pieces of it, okay? So the basics are you have the base station, which has power, it controls your temperature. You've got the pencil or the wand. A part of the pencil or the wand is the tip. And so if I hold this up, you're gonna see this tip is a really pointed tip. There's multiple different types of tips, and depending on what kind of soldering you're doing, you might swap out the tip that you're using. Now, we're in low voltage, audio-visual world. This is the tip we always use. We don't use other tips. You do want to make sure you're paying attention to manufacturer recommendations on that because not all tips can handle all temperatures. And so you're going to want to kind of pay attention to some of those details. Okay, so we've got base station, we've got the wand or the pencil, we've got the tip. Let me continue to talk through the pieces that are on my desk. You're gonna want some sort of holder. Most of the stations comes with a holder. If it doesn't, make sure that you buy something, because this is gonna be 1,000,000 degrees. Well, more like 800 degrees. But if you set it on the surface and the tip touches, it's gonna burn your table, it's gonna burn whatever you're touching. So you wanna make sure you have some sort of holder. And then the holders normally have a spot for a wet sponge. We've lost the sponge over the years, so now we've got a wet paper towel. And I'm gonna talk about that there's advantages and disadvantages to this. So this is your alternative to this. And maybe you just use them both. And here's what they are. When you're soldering, you're gonna need to eventually clean the tip of your pencil. And when you need to clean the tip of the pencil, what that means is that you've got solder that's starting to pool on the tip of your pencil, and you need to get rid of it. That's what this wet station here is for. But it being wet actually changes the temperature of your pencil. Because this is wet, it cools it down. And you can notice that your pencil is fluctuating in temperature too much, and then that's affecting the way that you're soldering. So instead of using a wet paper towel, you could use something like this. This is a little cup that's full of brass. And you can see it's just brass stuffed inside this cup. And when I put the pencil in there and it's got extra solder on it, the brass absorbs the solder, and then my pencil stays the same temperature. Now you might be thinking, hey, that's kind of picky, and it really depends on how particular the thing that you're soldering is, on if it really is being sensitive to temperature. We have moved over to primarily using brass because it does keep our pencil the same temperature. Also, the brass, it kind of like removes the solder away from it, kind of pulls it off the pencil, versus when you're using the paper towel or the wet sponge, you kind of have to roll it and kind of like clean it off, if that makes sense. So this is just a faster thing for us. Either one is fine, depending on what you're doing. Okay, so next thing is the solder. We really prefer, for low voltage, we really prefer thin solder. This is fairly low temperature solder. It's thin. This is rosin solder, which basically means that there's a chemical in it that helps it melt a little bit faster. If you go to Home Depot and you go buy solder, it's really thick. And what you might not know is it's not designed for low voltage. It's actually designed for plumbing. And will it melt? Yes, but it's gonna be goopy and large because it's designed for fitting copper pipes together, not for low voltage, small electrical wires and stuff. So we really prefer to get thin solder. This right here is, this is 1 millimeter is the diameter of this particular solder. You can get it in different things. Go online, you can look up 1 millimeter, or you can get smaller, but we really recommend kind of this thinner solder stuff. Also, it's very malleable. I can control it. So I can, if you see, I've got my solder now, and now I'm in control of my solder. I can push it into this little small location. This is a DMX plate, but I can push it into a small location, and it's got a lot of, like, I don't know, it's flexible, it's controllable. I can make it do what I want it to do. Versus if it's really thick solder, it's really gonna be hard to move and it's gonna make a mess. So you don't wanna use that stuff when you're doing low voltage AV work. You wanna use the small, good stuff. All right, now I'm gonna turn on my unit. And when I turn on my unit, I'm gonna turn this here. This particular unit has a light to communicate when my pencil's hot. While it's solid, that means it's warming up. When it begins to blink, that means it's at my target temperature. But what is my target temperature? What temperature should I be aiming for? Right now, I've got this station set to just about 750 degrees, which we've noticed for the solder that we use, that's the right temperature. It is somewhat solder dependent, so you could look that up about your solder, but I'll tell you like the little tips and tricks of what you're looking for when you, I paused because our unit, our pencil is losing connectivity. So what you didn't see, maybe you didn't see it on camera, maybe this camera over here caught it, but it started to blink and then it turned off. And then it started to blink again and then it turned off. And what that was communicating is that my pencil wasn't connected properly. So that's what the pause was for. We're at temperature now, and I can take my solder, I'm gonna do it over this so that I'm not dropping solder anywhere. But when I touch the solder to my pencil, it just really melts nice and fast. And if we can get a close enough shot, you can see that that solder is a nice, pretty silver color, okay? And that's what you're looking for. You're looking for a real nice, pretty silver color. I'm gonna turn this up way too high. So now we're like 850 degrees. And what's gonna happen is that my solder is it's gonna burn. I'm gonna be so hot that I'm gonna burn the solder, and it's gonna kind of get this like a black color, which is what burnt stuff looks like. So when I do this, I can already see that it's bubbling improperly. I don't know if you can see that on camera. It's bubbling wrong. And then if I can try to hold it like that, you see this burnt part right there? That means my wand is too hot. I'm burning the solder. So you could look up what temperature your solder really recommends, or you can be paying attention. You don't want to burn your solder. You want it to be that really pretty silver color without anything negative happening to it. So I made my solder really hot. I used my paper towel here, my wet paper towel, to cool the tip down. So now I'm back to my normal temperature. And if I melt that again, once again, I'm just trying to show you what you're looking for. See that nice, pretty bubble? That's what you did. That's what you're looking for. You need to tin the tip of your solder. This is what I've been doing. I wasn't doing it on purpose to make sure that my soldering iron was tinned, because it was already tinned. But that's the process. As you heat it up, we're talking about if you've got a brand new tip, you're getting it out of the box, you're getting it ready, you heat it up, and then you're just taking solder on it and you're melting the solder on the tip so that the tip has a coat of solder on it, and then you're cleaning the excess off so that your tip looks like a nice, clean solder. And that's gonna help you really with making sure that your solder is not getting burnt when you're putting it into your new electronics. Tinning is also used in the same way when you're talking about prepping your wire. Now this video is not about wire, but you should know this. When you're tinning your wire, you want your wire to have a coat of solder on it, in the same way that you want your soldering iron to have a coat of solder on it. So what I'm gonna do here, now I've got my wire out here. And if you have watched the XLR video, maybe you'll remember some of this, but I'm going to heat up my wire, and I'm taking my pencil and I'm putting it to the wire to make the wire hot, not melting solder straight on it. And then my solder, once the wire gets hot enough, my solder, see if I can get this started here. Oh, there it goes. All right, so my solder is actually getting sucked down the wire. The wire gets hot. In fact, I just touched it. I can feel how hot it is down here in the jacket. The wire gets hot, and it gets so hot that it pulls the solder down into the wire. And that's called the capillary effect. And that's what you're working on when you are trying to tin your wire. What you're not trying to do, and I'm gonna do it the wrong way, just so you can see the wrong way. The wrong way is I've got my soldering iron here. I put solder on my soldering iron and then I like paint my wire like this. And while it looks like I soldered it, at the end of the day, really what I did is I just put like solder on the outside of it. There's no solder inside the wire. And so when you're dealing with stranded wire, which we do in low voltage, you know, there's 30, 40, 50 strands of wire, and we really want that solder to be inside the entire wire, not just painted on the top of it. And I'm not gonna be able to do it, but technically if I mess with this enough, I could probably just flake that solder off. And so you don't want it like that. You really want it into the wire. So now you can see, okay, I've got all this excess solder. That means I need to clean my tip because I got too much stuff. There's the brass. And so the brass is gonna just pull that off, or I can do this and I can clean it on my wet paper towel, okay? That is the basics. That's the business. That's soldering. That's a little bit of tips and tricks. And you can apply that knowledge to other things. So we've gone over XLR here. These are stranded wire. If you are doing some different types of soldering, well, then this is at least get you started, to get you headed in the right direction. Well, thanks for joining us for another episode of Knowledge Basics. If you feel like you're learning something, then make sure you subscribe. That's how you get the notifications that a new video has dropped. Dropping it like it's hot. Make sure you hit the thumbs up. Tell us, hey, that was a cool content. Or you could leave a comment. In the comment section, you could say, Bruce, you're an idiot. And guess what? I'll probably agree with you. See you next time on Knowledge Basics.